Hello, morning, dear student friends. In this class, we are going to discuss SN2 reaction. As I told you in my previous class, we have discussed many things on substitution, nucleophilic, aliphatic reactions, that is aliphatic nucleophilic substitution reactions. In aliphatic nucleophilic substitution reactions, I further told you that there are many important reactions. One such important reaction is SN2 reaction, that is substitution nucleophilic bimolecular reaction. And the second reaction is substitution nucleophilic unimolecular reaction, or simply SN1 reaction. And we have few more reactions are there, and one more important thing is substitution nucleophilic internal reaction we have, that is SNI. These are the three important reactions as far as aliphatic nucleophilic substitution reactions are concerned. We will discuss one by one, and in the series of aliphatic nucleophilic substitution reactions, the first reaction we are going to discuss now is SN2 reaction, or simply substitution nucleophilic bimolecular reaction. Substitution nucleophilic bimolecular reaction. That is SN2, where S is substitution, N is nucleophilic, 2 stands for bimolecular, that is bimolecule, because this reaction requires two molecules to proceed, proceed. Therefore, this is bimolecular reaction. For this, we have evidence also that there are two molecules involved in this SN2 substitution. Let us consider a simple reaction in which we have Rx plus Y minus gives you Ry plus X minus. Remember, this Y minus is nothing but your entering group, that is nucleophile. This is the one going to substitute in this aliphatic nucleophilic substitution reaction, that is in this SN2 substitution. This is the entering group, this carries minus. As I told you, there are 4 different possibilities, there are 4 different options we have as far as substitution nucleophilic aliphatic is concerned. We have discussed all the 4 different types. If you want further clarification, please refer my previous session under the topic aliphatic nucleophilic substitution reaction. Now this is Y minus is your entering group, this carries minus charge, and this is your, as usual, this is your substrate, and this is in this X part is called your leaving group. This is entering group, Y minus is your entering group, and X is your leaving group. This is entering group and this is leaving group. This is the one, during the course of the reaction, this is the one that leaves out of this substrate, and in the place of X, Y comes and taken this position. This is the reason why this is leaving and this is entering. The simple reaction in which Rx with the help of Y minus is converted into Ry and X minus. This is your leaving, and this has entered already in the product. Therefore, this particular thing is called entering group. See the reaction. And in this particular reaction, SN2 reaction, remember there is a backside attack. Backside attack by Y minus into the substrate takes place exactly 180 degree away from the leaving group. The position, the angle between these two is 180 degree. And this Y minus attacks the substrate from backside, because for this alkyl halide RX, this is the back. Therefore, Y minus attacks the substrate from the back and it will be converted into like this. Always in SN2 there is a backside attack. RX we have, and this will be converted into say for example take alkyl halide, and it will be converted like this. So X, and finally it will be converted into YC plus X minus. This is your product. And this is the one I told you that this leaves out of the substrate, after that is leaving group, that has to go. The moment during the course of the reaction, see the reaction? During the course of the reaction, as I told you, the entering group attacks the substrate from the back side. As a result, it will be converted directly into the product via a transition state, wherein you can see the Y, there is a partial bond between Y and C, partial bond formation, and the partial bond is there between the substrate, the carbon of the substrate, and X. This is the transition state. This is nothing but the state wherein there are 5 atoms are there. The carbon is connected with 5 different things. Of course, this is not possible, because at no time the carbon can bear more than 8 electrons. Its octet has to maintain. This is the reason why these things are written in the dotted lines. There is a partial bond is found between C and Y, and the partial bond is there between. Originally the bond between C and X is strong, and in the transition state, of course this is not the transition state, it's just for imaginary purpose, just to explain the concept. This is the thing where this thing exists. This you cannot trap, or this you cannot be isolated. This is the reason why this is not actually the transition state. There is a partial bond is there between the entering and the carbon of the substrate, and there is a partial bond is there between the carbon and the leaving group of the substrate. And finally, there is a product is formed wherein you can find the inverted configuration. The product with inverted configuration is there. Inverted configuration is possible in this. The product is inverted one. As far as the stereochemistry is concerned, the product is inverted one. Inversion of configuration has taken place while the substrate is converted into the product in the course of this particular SN2 substitution, because there is a backside attack. Backside makes this substrate into a reverted product. Reverted product you get, the product what you get finally is an inverted product. Therefore, this is as far as the stereochemical aspect is concerned, the inversion of configuration is there in the product, in the substrate. This is the substrate, alkyl halide you have taken, and the Y minus is attacking the substrate 180 degree away from the leaving group. This is the transition state. This is actually that energy curve of energy of free that is free energy of activation energy curve. This is the position of the atoms at the top of free energy of activation. The curve of free energy of activation. And once this particular transition state is reached at the top of this free energy of activation, the only option available for this transition state is to convert into product. That is, it has to invert because of the backside attack of the substrate. This is one evidence for this your SN2 substitution reaction. The Cx, the energy, and one more clarification is there as far as the SN2 is concerned. The energy necessary to break the Cx bond is supplied by the energy is supplied by the nucleophilic when it is attacking, when it is forming the bond between the carbon of the substrate and the nucleophile. The energy required to break the Cx is supplied by the simultaneous formation of the C and Y bond. Remember, we require at least some energy to break this bond, C and X bond. The energy required to break this bond is supplied by the simultaneous formation of C and Y. There is a simultaneous formation of the nucleophile, that is a entering group with the carbon of the substrate, and simultaneous movement of, that is a removal of the C and Y is taking place as far as this SN2 is concerned, that is this particular reaction is concerned. Remember, this is a one-step reaction. This is just a one-step reaction. The formation of formation of Cy and removal of Cx is taking place simultaneously in a single step. This is a single step reaction. Of course, the inverted product is formed finally because of the backside attack. Backside attack of the nucleophile to the substrate, making the substrate completely inverted. Like the umbrella is, you know that there is an inversion of umbrella. This umbrella is completely inverted because of the heavy wind. Similarly here, the backside is forcing the substrate into an inverted configuration. The substrate is moved completely into inverted configuration. This is one stereochemical evidence we have for this SN2 substitution reaction. Now come to see the board. Incoming group, substrate, that is the position of the atoms at the top of free energy of activation of the curve, and finally product with inverted configuration, and X minus is leaved out of the substrate. This is a reaction. Substitution nucleophilic bimolecular. There are two molecules involved in this reaction. One is the substrate, another one is the nucleophile. Without the nucleophile and without this, there will be no SN2 reaction. This is the reason why this is called a bimolecular substitution. Molecule number 1 and molecule number 2. There are two molecules involved in this reaction, therefore we have two here. Substitution nucleophilic bimolecular reaction. Now come to the evidence. As I told you, we have the stereochemical evidence in which we have that we have discussed regarding the inverted configuration is one important evidence we have as far as the stereochemical aspect of this SN2 is concerned. And the second evidence is kinetic evidence we have to prove that this is SN2 reaction, kinetic evidence. As I told you that there are two molecules required to carry out this particular reaction, Ry plus X minus. In between there is a transition state. It is not transition state because you can't track this, you can't isolate this, you can't study the transition state. Just imaginary state. And finally YR plus X minus. This is your inverted product with the inversion of configuration. Product with inverted configuration. Product with inverted configuration. Now regarding the kinetic evidence, it is a bimolecular reaction we know very well. One is this, another is this. Molecule number 1, molecule number 2. Kinetic evidence confirm that nucleophile and the substrate are involved in the rate determining step of this SN2 reaction, because there is only one step here. This is the only step we have taken. There is we have to carry out to study the rate of this reaction. We can study the rate of this reaction having this particular reaction. There is only one reaction, remember. Therefore, there is no second such reaction. There is no second reaction in this. This we are taking to study the rate of this reaction. What is the rate of the reaction? Nothing but what extent to what speed. Rate is nothing but the speed of a reaction. The speed of this particular reaction can be studied with the help of this particular reaction, because there is only one reaction. Therefore, this particular step is also called as a rate determining step. We are using this particular step of SN2 substitution to study the rate of this reaction, the speed of this reaction. Therefore, this is called the rate determining step. This is the step we have taken into consideration because there is no second step to study the speed of this reaction. Therefore, this is called a rate determining step. Rate determining step. And since we have taken this to consider the rate of the reaction, overall the rate equation now follows like this. Rate is equal to K concentration of Y minus and concentration of X. This bracket in science, as far as science is chemistry is concerned, this bracket refers to your concentration. Concentration of substrate multiplied by concentration of incoming group, that is the nucleophile. K is rate constant. K is a constant. This constant is called the rate constant. The rate of this reaction is equal to rate constant, that is K multiplied by nucleophile concentration and multiplied by your concentration of the substrate. With respect to order of this reaction is concerned, this is a second order reaction. Second order reaction. Order, first order with respect to nucleophile, second order with respect to substrate. What is order of a reaction? Order is nothing but sum of the powers of concentration terms involved in the rate equation is nothing but order of the reaction. I repeat, sum, that is total, SUM. Total of the powers of, here for this nucleophile concentration is concerned, the power is 1, and for this concentration of substrate is concerned, power 2. Sum of the powers 1 plus 1, therefore this is equal to 2. Sum of the powers of concentration of the nucleophile and the substrate is nothing but order of this reaction. Therefore, the order is equal to second, that is 2. Therefore, this is a second order reaction. This follows second order kinetics. We can arrive at the conclusion that we are inferring finally, after the discussion is over, that this is, as far as the molecule is concerned, this is bimolecular. As far as the kinetic evidence is concerned, this is second order kinetics. This follows second order kinetics. Second order kinetics. Of course, this particular thing, explanation, infers finally that this is a second order kinetics. Remember, this is not always the same. Say for example, if the nucleophile is solvent, let us assume we have taken the nucleophile in the form of solvent, where naturally the solvent is always in excess. We cannot take into consideration the entire concentration of the solvent because of its large volume when compared to the substrate. It's simply negligible. We never consider the concentration of the solvent, because in this example, what we have taken to measure the speed of this reaction, the nucleophile is in the form of solvent. The solvent concentration is too much concerned compared to your substrate, therefore this is negligible. We are not taken into consideration. In that case, the rate follows still bimolecular. Sorry, the reaction follows still bimolecular because nucleophile is required. Of course, this is in the form of solvent. Anyway, molecule number 1 is nucleophile in the form of solvent, and substrate is there, that is second molecule. Therefore, molecule wise bimolecular, whereas order wise it is just first order. Remember, first order. As I told you that we never consider if the nucleophile is in the form of solvent, its concentration we never consider to calculate the rate of the reaction because its concentration is too high compared to the substrate concentration. Now I am writing the rate equation. Rate is equal to K, concentration of substrate alone, no concentration of your nucleophile. This particular thing, remember, the reaction follows bimolecular, no doubt. Again, this reaction is a bimolecular reaction, whereas order concerned, with respect to order is concerned, this is first order kinetics. This proves that this is first order kinetics because of excess amount of the solvent in which we have the nucleophile. This particular reaction is called pseudo first order reaction. Pseudo first order reaction. Pseudo first order reaction. Pseudo means wrong. Meaning of pseudo is wrong. Wrong first order reaction. It is not perfect first order reaction. Remember, it is not a perfect first order reaction. That's why we have prefixed the word pseudo first order reaction. Wrong first order reaction. Pseudo first, the correct term as far as the chemistry is concerned, organic science is concerned, pseudo is the correct word we have to use. Pseudo first order kinetics. This follows this pseudo first order reaction, or this particular reaction follows pseudo first order kinetics. I repeat, if the reaction is original, wherein the nucleophile and the substrate concentration is limited in the sense we have taken that is the enough molecule of your substrate, enough molecule of nucleophile. In that case, the reaction follows bimolecular and the kinetic follows second order. Kinetics is now second order. On the other hand, if the nucleophile is in the form of solvent, again the reaction follows bimolecular. The reaction is bimolecular, no change. Here also 2 molecules are required, and in the second also, that is pseudo first order reaction also, 2 molecules are required. One is nucleophile, of course, that is in the form of solvent, and the second is concentration of the substrate. Therefore, this is bimolecular. And order wise, now this is first order kinetics, because we are not taken into consideration the second part, that is the nucleophile part. Concentration of the nucleophile we are not taken into consideration to calculate the rate of this reaction because of the concentration of the substrate. The concentration of the nucleophile is too high compared to the substrate. Therefore, this is negligible when comparing the substrate concentration. Therefore, we are writing only the concentration of the substrate in the rate equation. And for this reason, this is called first order reaction, not original first order, pseudo first order reaction. Pseudo first order reaction. We have second evidence for this SN2 is concerned. I think this is more than enough because you are in the undergraduate level. This is more than enough as far as the substitution nucleophilic bimolecular reaction is concerned. With this, now I am concluding my discussion on substitution nucleophilic bimolecular reaction. See the board for more clarification again. Please let me know if you have any doubt. If you have any doubt in that looking the board, clarification of the board, because the board is a white board. If there is any if you feel any difficulty in that is my handwriting, my voice clarity, let me know please, so that I will correct in my next class. Thank you.